All right, so solving exponential and logarithmic equations. We already solved the easy kind, so the kind where you get a common base and the kind where you just look at it and you can come up with an equation. Now, here's what you need to be able to do, and this is going to be the new information. We can write a logarithm in an exponential form and vice versa. So what you need to remember is that logarithm is exponent, right? So we wrote this down at some point. So we have log of something equals the exponent, right? So here's how I'm going to translate this to you. If you have something in exponential form, so let's think of something like 2 cubed, we know is 8, right? We know 2 is called the base. 3 then would be the exponent. And then it's equal to this value, right? 8 is the value. Well, if I want to switch that to logarithmic form, it's log with a base of 2, so base is still the same word, of something is the exponent, 3. So log base 2 of 8 equals 3. You have to be able to switch between those two forms. Why is this important? Well, if you remember, we found inverses. And I told you, okay, if you have a function y equals to the x, we know that the inverse is y equals log base 2 of x, because we saw that graphically and using equations and all that. But we also know that in order to find an inverse, you switch x and y, and then you solve for y. But you see how that y is in the exponent? Well, we can't undo a base of 2 without a log. So logarithms bring down exponents. So let me say that again. Logarithms bring down exponents. That's important. So if we change this to log form, we say log base 2 of something is the exponent. The third thing goes in there. And we have the inverse, right? That was what we said the inverse should be. So that's what we're going to practice doing today, is changing the form. So I'll say change the form if you get stuck when solving. Because sometimes it's easy and you just need a common base, but then sometimes it's not so easy and you need to change the form. Now, the reason I don't use letters for exponential form to logarithmic form is because then you can always check that you've got the right thing going on your calculator. So you know that 2, whoops, if I could do that right, you know that 2 cubed is equal to 8. So then watch this. Log base 2 of 8 equals 3. But if you ever get stuck and you're like, wait, is it log base 2 of 3 equals 8? And you'll say, oh, no, that's not it. I must have it wrong. Okay, so you can get the proper forms without having to memorize something crazy. All right, so we're going to solve these equations. I'm going to show you how to change the form, and you're going to get really, really good at it, I promise. So it says solve each equation for all values of x, round to the nearest thousandth if necessary. Thousandth is 3 decimals in our answer, so we need to look at the fourth, and that'll tell us to stay or raise. So in example 3, I have log x equals 10. Well, I can't divide by the word log to solve for x. That's not a thing. I have to be able to undo a logarithm. The inverse of a logarithm is an exponential. So what we're going to do is we're going to change the form. But there's one thing we need to know first. What is the base of this log? If a base isn't written, it's either e or ln, and so since this says log, it's base, or it's either e or 10, sorry. Base 10 here. So we're going to change it to exponential form. So that little 10 down there is the big base of our logarithmic function. What's inside with the log, so what's after the g, is x, And that ends up on the other side of the equal sign. And what's on the other side of the equal sign is a 10, and that becomes the exponent. Now 10 to the 10th is a really big number, so I'm just going to leave it like that. Okay? And it's over. So example 4. We have something that's in exponential form, and we're going to change it into logarithmic form. So we're going to convert this way. So the only way to bring down an exponent is to use a logarithm. So log with a base of 5 of something is, meaning equals, the exponent. Now I know the 12 goes in the parentheses, and I can use my calculator. Calculator, let's see. Log base 5 of 12. 1.5439. The 9 tells me to raise. So 1.544. Fabulous. Okay. So let's do a few more of these. Let's just see what's coming next here. Okay. So we're just doing some baby ones. So let's see here. All right. We have something that's in exponential form. We're going to change it to log form because we want to solve for x, which is in the exponent. So log base 3 of something is equal to the exponent. So 81 goes inside here. So go to your calculator. Log base 3 of 81 is 4. I'm actually going to shrink my calculator here. Put it over there. Okay. What did I say? 4? X equals 4. Fabulous. All right. Number 2. We have a log equation, but we can't solve for x the way it's written. So that means we have to change the form. So I need to change to exponential form. This log has a base of x, and I know logarithm is exponent. So on the other side of that equals is a 2, so that's the exponent. Equals, the only other number is 4. X squared equals 4. Well, technically, you could square root both sides, but you're going to forget something. So I would say it's a polynomial or a quadratic. We get it set equal to 0. Factor. Difference of 2 squares. And we get 2 answers. X equals -2 and x equals +2. And you should remember from yesterday that in log equations, you must check your answer from a log equation. So let's go back to our calculator. Log base x of 4. Okay. Log base -2 of, hold on a second here. There we go. You know, I'm gonna do that again. I don't like what I just did. Okay, let's store it. -2. I like to use k. So log base k of 4 should be equal to 2. It tells me there's an error. Uh-oh, so that means it can't be -2. Let's see here. Now I'm going to store +2. No, I don't need to actually store. I get that, but I'm going to copy. Is that equal to 2? Yeah. So just one answer. Okay. Number 3, we're back to an exponential form. So there's an x in the exponent. The only thing that brings down an exponent is a logarithm. So we change it to log base e of something is equal to the exponent. So inside those parentheses is the number 4. Log base e is called the natural log. We abbreviate it. So ln of 4 is equal to 2x. And we actually have one more move in order to solve here, and that's to divide by 2. So, let's see what our calculator says. I like to clear it every time. ln, I don't even remember what it was now, of 4 divided by 2. 0.6931. So the 1 tells me to stay at 0.693. So x equals 0.693. All right. Number 4. We have a logarithm, and inside the log, we want to solve for x. You can't divide by a word. You can't divide by a word. So we need to change the form to exponential. This log, because there's no base written, we're supposed to understand it's base 10. So 10, logarithm is exponent. So after that equal sign is the exponent. Base 10 cubed is equal to x. Well, 10 cubed is what? 1,000? Is equal to x. So let's check. It's a log equation we must check. So is log of 1,000, log base 10 of 1,000 equal to 3? Yeah, beautiful. Okay. So these directions should look the same as normal. We're going to round to the nearest hundredth now if necessary, which is 2 decimals, which means we need to look at third to stay or raise. Basic steps of solving an equation: get the weird thing alone, undo the weird thing, solve for x, check for extraneous solutions in log equations. Okay? So the weird thing, to undo the weird thing, we're going to change the form in both situations. Okay? So it looks like, yeah, they're all mixed up in here. Cute. Great. Good and great. Great and good. So I'm only going to go through a couple of these, and I'm going to have you try some on your own with your group. So example 5, step 1, get the weird thing alone. So the weird thing is e to the 3x. So I want to try to get that alone. So the first thing I'm going to do is divide by 4. So I have e to the 3x equals 1/4. But x is in the exponent, so I need to bring down the exponent. The only thing that brings down an exponent is a logarithm. So I'm going to change the form to undo it. Log base e of something is exponent 3x. So the 1/4 goes in here. And I know that log base e is actually natural log, ln, of 1/4 is equal to 3x. We need to solve for x. So we divide by 3. So x equals, all right, calculator, doc B, natural log of 1/4 divided by 3. Negative 0.462. The 2 tells me to stay, so negative 0.46. All right. Example 6. Step 1, get the weird thing alone. So again, we're getting e alone. How do we get this alone? Well, first I've got to move the 7. So 3 e to the x is equal to 2. Then we've got to get rid of the 3. So divide by 3. E to the x is equal to 2/3. Okay. Well, there's an x in the exponent. And so the only way to bring down that exponent is to use a logarithm. So we have to change the form. So it becomes log with a base of e of something equals the exponent. So in the parentheses is the 2/3. Log base e is really natural log of 2/3 is equal to x. So let's see what the calculator has to say about that. Natural log of 2/3 is negative 0.405. So 100th is 2 places. I'm looking at the 5 and it tells me to raise. So x equals negative 0.41. Okay, so you are going to do 5 and 6. I am going to show you how to do number 9, and you're going to do the rest as well. So show you how to do number 9 real quick. All right, number 9 looks kind of scary. I'm not going to lie to you. You're like, what is happening? Take a deep breath. Get the weird thing alone. The log is the weird thing, right? This whole thing is weird. And that 2 that's in front is being multiplied. So we're going to divide by 2 first. Log with a base of 7 of 1 minus 2x is equal to 6. Okay. We need what's inside the log. So we need like a chainsaw, right? No, we don't need a chainsaw. We need to change the form to an exponential. So the base of the logarithm is 7. We know logarithm is exponent, so 6 is the exponent, equals what's inside. Okay? So we're solving for x. Yikes. What is 7 to the 6th power? 117,649. Gross. 117,649 is equal to 1 minus 2x. So now we're just solving a linear equation, right? Subtract the 1. 117,648 equals negative 2x. Divide by negative 2. So let's see. Minus 1. Divided by 2. Oh, divided by negative 2. Woohoo! Negative 58,824. Gross. Get used to these big numbers. They're not going to go away. All right, so you are going to take a few minutes. Do the best you can with those. Check. Let's see, which ones do we have to check? Anything with a log we have to check. We have to check number 7. We have to check number 8. We have to check number 10. You don't have to check for extraneous roots in 5 and 6. Okay, so if there's a mistake, if you get an answer that doesn't check, you did something wrong. Okay, so I'm assuming you tried these. You took a few minutes to try them. Oh, I hate when it freezes like this. So I'm going to go a little faster through this because I'm assuming that you paused and tried. So first thing I want to do is get the weird thing alone. So I'm going to divide by 3 to get the exponential alone. And then x is in the exponent, so I'm going to change the form to log base 2 of 5 equals x plus 6. And the last thing I'm going to do is subtract the 6. So log base 2 of 5 minus 6 is equal to x. So negative 3.68. All right, number 6. Ooh, tricky. I'm going to get the weird thing alone, so add 8. To get rid of 3/4, I'm going to multiply by 4/3. E to the 3x equals 8 over 3. Then I'm going to change the form. Log base e of 8/3 is equal to 3x. I know log base e is actually natural log of 8/3 equals 3x. So the last thing I'm going to do is divide by 3 to get x alone. So the calculator negative point, or not negative, hello, 0.33, x equals 0.33. Okay, so now the 3 log equations. Get the weird thing alone. Well, the log is alone on the left. Undo the weird thing, so we're going to change to exponential. 4 to the 6th is equal to 3x. And then I'm going to divide by 3. So x equals whatever 4 to the 6 over 3 is. Yowza. Control divide. 4 to the 6th over, divided by 3. 4,096 over 3. Leave it. Everybody likes fractions better than decimals. Okay. And then we get to check. So I'm going to store that for k. Store for k. What was the equation? So log base 4 of 3k equals 6. So it checks and everything is good. Check. All right, number 8. Log of 7x plus 4 equals 5. So 2 things. First of all, get the weird thing alone. Log of 7x equals 1. Now we have to change the form, but there's no base written. So you have to know that it's base 10. 10 to the first is equal to 7x. Well, 10 to the first is 10, so divide by 7. X equals 10 over 7. Oh, we have to check. Let's check. So store 10 over 7. I'm going to clear. You should clear every time you store for a variable. It's just good habit. I sometimes don't, which is bad habits. So store for k, log base 10 of 7k plus 4 after the parentheses. Is that equal to 5? Ding, 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 ding. Doing a great job. Okay, so then number 10. Get the weird thing alone. It is. Undo the weird thing. So change it to exponential form. 3 logarithm is exponent, so squared, equals 3x minus 1. You know 3 squared is 9. Add the 1. Divide by 3. Baby linear equation. You can solve those in your sleep. So x equals 10/3. Let's check it. So let's clear doc B. 10/3. Store for k. What is it? 3x minus 1. Okay, so, oops. Log base 3 of 3k minus 1 is equal to 2. Yeah, that's right. Yay! Okay, so good. Fabulous. All right, now, all of this here is really practice for your upcoming quiz, right? So, graphing exponential and logarithmic functions. It has, was that right? Yeah, okay. So we have 2 to the x and e to the x, log x and ln x. I have these up here because these are things we see a lot of. We see 2 to the x a lot. We see e to the x, log base 10, and ln of x a lot in terms of graphing or other things. Their domains and ranges and asymptotes are written there. So what I want to remind you of is that the asymptotes for an exponential they start at y equals 0, and they only change if you're adding or subtracting on the outside. And then for logarithmic, the asymptotes are x equals 0, so they're vertical, right? These are vertical. So the only time these asymptotes change are when you have a change on the inside. So inside the logarithm, left, right. So what you're going to do is you're going to go through here and you're going to describe what transformations are happening and determine the equation of the asymptote. Okay, so you're starting with an asymptote of x equals 0, y equals 0. Do the transformations move it at all? So you're going to do that, and then writing inverses. We just talked about that. We did this on day 2, I believe, day 2 or 3, I can't remember. And then this is a set of equations that are all mixed up. So if you look at number 16, this is from day 4, day 4. This is from day 2, day 2. This is from day 4, this one's from today. So then you you get into the kinds where you have to change the form. And actually knowing when to change the form and when not to change the form is actually a big deal. So a lot of things going on here. So I will give you an advice here. Here you want a base. I would use 2. Here you want a base of 5. Here you're going to use reciprocal exponents. 19, same thing. 20 is the easy kind. Just look at it. Easy. Yeah. And don't forget to check. Then number 21, you're going to change the form. Okay, change the form. 22, x is inside the log, so you need to change the form. And you need to check it. 21, you need to check it. 23, x is inside the log, so you have to change the form, and you have to check it. And then 24, you're like, wait a minute, which one is not like the others? Yeah. So this, you need a common base. The easiest base to work with is 2. And then that's it. Okay? Do a nice job. I'll flash some answers. So I want to make sure we have the asymptotes right. I think you're probably going to have your transformations right. So in number 1, there is no vertical change, so it remains y equals 0. Number 3, there's a vertical shift up 3, so the asymptote is y equals 3. Number 5, there's a vertical change of down 6. The asymptote is y is negative 6. Number 7, vertical change up 4. Asymptote is y equals 4. Number 9, go up 11, so asymptote is y equals 11. For exponentials, that's for exponentials. For logarithms, the only change happens if there's a transformation in the inside, so with the x's. So we go right 1, so x equals 1 is the asymptote. Number 4, there's no horizontal shift, so x equals 0. 6, we go to the right 5, so x equals 5. 8, there's no horizontal shift, so x equals 0. Okay, I'm sure you have your transformations. Oh, this one is a reflection in the y-axis. That was a dirty trick. Okay. Okay, so we know that exponentials and logs are inverses. So you can see in this little example here, 2 to the x, log base 2 of x. E to the x, ln of x. 3 to the x, log base 3 of x. So 5 to the x, log base 5 of x. Log base 6 of x, 6 to the x. 7 to the x, log base 7 of x. Log base 4, 4 to the x. log base, or b to the x, log base b. Log base k of x becomes k of x. K to the x, sorry, I said that wrong. It's hard to say this really fast. All right, so then you had to solve these equations too. Okay, so 16 should be 1, 17, negative 3, 18, 11, 19, 79, 20, 0, 21, 16 over 5. Don't give me a decimal. Leave 16 over 5. So you had to check 20 and 21. They both check. Make sure you pause it and correct any mistakes here that you have. You want to be able to do this on your quiz. All right, and then the last three, 22 and 23, you had to change the form and check. So again, pause it if you need to look at each of these. 24, common base is 2. Did you distribute when you multiplied the exponents? Get it set equal to 0. Factor, which you had to split the middle. And you get 2 solutions, 2 and negative 7/5. So again, pause it, see if you can find your mistake and fix it. Okay? Be ready for your quiz, okay? Do a good job with this.